This is problem 2344. And I have worked through this problem because I recorded it and then I found multiple errors. So I decided to go back and just fix the errors and then go through it now. So what we have is this equation for voltage as a function of x and y. In this case, A and B are specified in the problem, and we'll plug those in later. Now notice the units for A are volts per meter cubed, and the units for x and y are meters. So we'll have meters squared times meters, which is meters cubed, which will cancel out with the meters in the denominator, which will leave an answer in volts. The same with B. Now the electric field in the x direction is equal to negative the partial derivative of the voltage with respect to x. So the derivative of this with respect to x is you take the derivative of x squared, which is 2x. You've got the negative sign, and you multiply by a times y, which are treated as constants in this partial derivative. In the second case, we take the derivative of x with respect to x, which is 1. So what we're left with is by squared, and then you change the sign. And here I just changed the order, negative 2axy. So that's the equation for the x component of the electric field. Now you do the same thing for the y component. It's negative the partial derivative of v with respect to y. So we go back here to the equation for the voltage. Take the derivative with respect to y. It's 1, so we're left with ax squared, and then the negative sign. And secondly, here we take the derivative of a y squared with respect to y. That gives us 2y. This negative becomes positive because of this negative sign, and then we reorder them to bxy. Okay, so those are the equations for the derivatives of of the voltage with respect to x and y. Then we can plug in A and B. So A is 5 volts per meter cubed, B is 8 volts per meter cubed into this equation. And once you multiply everything out, simplify it, you've got negative 10xy plus 8y squared. You do the same thing for the y component of the electric field. So you have negative ax squared, negative ax squared plus 2b x times y. And 2 times 8 is 16. So those are the equations. And now we just evaluate those equations at a particular combination of x, y, and z. So if we take e sub x, and I can see I've made a mistake here, so let me pause it. Okay, so the equation for e sub x is 10, negative 10, xy. So I put x of 2, y of 0.4, plus 8 times y squared, 8 times y squared. And you plug that in your calculator. Make sure you have the negative sign here, positive sign here. You get negative 6.92 volts per meter. So that's the x component. For the y, you've got negative 5x squared plus 16xy. So we've got negative 5x is 2 squared plus 16 times 2 times 0.4, x times y, you get negative 7.2 volts per meter. So those are the components, and then you could rewrite the electric field vector at that particular point is going to be equal to negative 6.72 volts per meter I minus .20 volts per meter J. So that's the vector. And remember that, I forgot what I was going to say. You know, you could write it as this as well, negative 6.72 comma negative 7.2.